in a room full of agenda with super cool airplane products, I got the least exciting assignment here, making manufacturing the cool topic. I can tell you after spending about a decade in the aircraft creation phase, and the phase that we're in right now is some of the coolest and most rewarding, and it's some of the best times of my life. I'll also tell you that the phase of having to bring that theory and that conception into reality, into a productionized, sophisticated vehicle, is some of the most challenging, difficult, character testing moments of my life. Seriously, and for those who have done it, they'll tell you it'll bring it to your knees if it doesn't bring it to your death. So, with that in mind, today I'll go through a few things kind of quickly here. I'll give you a contextual overview of who Icon is, so you have some context to figure out what's relevant and what's not. I'll talk about manufacturing process for us, how we do it, and then Eric and I'll talk about some lessons learned. So aside from manufacturing, what would Icon have in common with Uber, Elevate? We burn dinosaurs. We are not for commercial transportation. We're a fun plane. I'll tell you, but at our core, we have the same vision, and that's to democratize flying at the personal level. The question is how do you get there? In fact, if you walk in our office, you'll see this on the wall. And we believe that there's something about flying that inspires all of us and has for a long time. And it's sort of the ultimate metaphor for human freedom. We also believe that where we are today is not where we can be, that personal flying can be a lot more, and that given the regulation changes that are happening now and new technologies, what's cool is the next 10, 20 years of aviation does not have to look like the last 10 or 20. So our mission is to reinvent flying, same we're talking about today. Bring back the freedom, and for us, it's the adventure of flying, and then ultimately to do the same thing, and that's democratize personal flight. And our model is at the personal ownership level. So before I get to manufacturing, let me tell you what the design drivers that drove our vehicles so you can relate to it. For us, it was the user experience. We talk about had to be easy, had to be safe, had to be fun, had to be cool, aesthetically pleasing, and for us, versatile. That doesn't sound like much, but what happens for us, it created a very, very difficult problem, which I think is analogous to what we're going through here. That problem is that, for us, being very consumer-focused, meaning that product need to have a sophisticated consumer product experience, and that drives your design and your complexity. Had to be productionized, and if you've ever flown in small planes, you'll know that most little planes don't inspire confidence. And so humans at the mass scale want to have confidence in their product. That drives difficulty. Volumes, Eric talked about this. If you're doing 50, 100 planes a year today, that's a lot. Those for small planes at the top of the food chain are doing 300. So for our assumption, we started at a break even about 300 and building a business that would ideally run about 1,000, but that's a big assumption. Weight, and so for us, we had a regulatory constraint which was really hard for us. Our empty weight's about 1,000 pounds. You'll have a similar problem because of the physics. But what happens is that the result of all these things for us mean that for our solution, we were looking at an all-carbon fiber complex structure, which is difficult design, difficult to make, and difficult to manufacture at scale. So simple airplane, hard structure. This is the airplane. For those who don't know, haven't seen it, two-seat, folding wing, simplified cockpit, operates off of land or airports, operates off of water. It's intended to be a consumer product, keep it at your house, with a whole bunch of safety features. So that's our product. Let's make it. So it's funny you mentioned McLaren, Eric, because I would describe our manufacturing as if McLaren got together with General Atomics and said, let's make a consumer airplane, it looks about like this for us. I'll walk you through our process. We have our final assemblies is up in Vacaville. We have a new plant down in Mexico, which we built. When I first started, we did not want to do our own carbon fiber. I wanted Acme Aerostructures that could build low-cost carbon fibers at rate at these cost structure. Turns out it didn't exist. We had to go build that supply chain for our own. Just for scale, about 90% of the labor in the vehicle is in the structure itself. That's our plant in Tijuana. state of the art as we can get right now. We have, and what you'll find out besides the tooling process that you'll go for these is very expensive and very complex, but that's how you have to get rate. These are not hand-built one at a time. Finishing, get shipped up to Vacaville. That's our factory there. And assembly line, they will look much like if you visited McLaren or Ferrari, you see a very similar line like this. That's how we make them. So that's it. So Eric, you want to come up and we'll talk about some of the lessons learned?
All right, thanks, Kirk. So I think that you can see how there are quite a lot of similarities, even though there's a lot of differences, between what you're talking about and what we're talking about. So let's talk about this a little bit. Let's dig into it and discuss some of the lessons, the important lessons that you learned in doing this, and think about like how we apply these lessons to our ecosystem going forward. So let's just review. You said that your target was in building out your factories was about 300 and.
Yeah, so you got to pick a starting point, and the demand you think you might have drives that assumption, and there's some initial volume that you'll begin with that then you scale off of, and that's an important assumption. So for us, I mean, the way you make 50 products versus 500 is different, and most airplane companies are making 50 or 100. So we chose something that was kind of 500-ish. But could scale to a few thousand, which is kind of a sweet spot for what you're talking about. But that's a critical assumption because the amount of engineering and tooling and work that goes into get something ready to scale fairly quickly to 500 to 1,000 as an airplane is not the same as how you make 50. They're vastly different.
Right, so that's a really critical point that we were digging into a little bit before we came up here on stage, that you have to make that projection to the total addressable market that you think you can go after ultimately, and like bake that into the early work that you do. And if you don't do that right...
Yeah, exactly.
Yeah.
It's a bit chicken and egg because you have to, I mean, you're making a bet that the market's there, and you're making massive investments in a manufacturing system that can support that market at scale. And if you don't get there, this is wasted.
Yeah. So it's a critical.
And if you go cheap, then you can't scale.
Yep. You just have to adding labor does not make the cost go down.
Yeah, it's tough.
So this is actually it's a good analogy to kind of some of the stuff that I was talking about before, that we are trying to paint, look into the future, paint this picture of like what the end point is, so that we make good decisions now, exactly along those lines about how do we kind of like tick-tock up to get there. So you said your ultimate kind of targets at scale in the processes that you're doing right now are something like 1,000. You think you could scale it up to 1,000 or a couple thousand per year under that existing cost structure.
Our starting point, we could scale to 1,000.
Okay.
Break even around 300, but that's what we chose for our initial.
So what do you think you would have done differently in this spirit? That's why I didn't tell you this one ahead of time. But if you were to scale to say, money 5,000 or 10,000 as like kind of that starting point, not
starting
to
at 5 or 10,
not to scale to 1,000.
I mean, making composites is a very labor-intensive process.
Yeah.
I mean, BMW probably do some of the best work in their investments and how they do high-rate carbon fiber. But I'll tell you, the weight constraint is so problematic for us that we found that the material properties that we need for our airframe, for that airplane, is closer to satellite technology than it is anything else. So it's very high performing. It's hard to make, and you have complex forms and things. So until we crack the code on how to automate that, it's a very labor-intensive process.
So you think that essentially the automation, though, of that composite airframe is kind of the key thing that unlocks like the next
if
step.
you can. I'm not sure. I'm not sure where it is. I'm not sure we can get there just yet.
Yeah.
And then for us, investing and making those are big investments to do 5,000 a year, 10,000 a year. So we're cheating off base away from where aviation is today, without making the full commitment that we're going to darken the skies.
So that's super interesting. So thinking about kind of the lessons that you've learned in scaling up to kind of where you're at right now, and you guys have started production now in the Tijuana factory, is that correct?
Yep.
And there's probably lessons that are appropriate for little companies and lessons that are appropriate for big companies. what do you think some of the key takeaways of kind of this, as you said, a character building experience that you've gone through to get to this level of manufacturing in these vehicles right now?
I would say that, well, the first thing I'd be for anybody is to be very, very careful about compounding optimism. Optimistic.
I don't know anything about that, Kirk.
Raise the optimistic power, raise the optimistic power can quickly give you sort of divergent realities. And so, and ultimately you have to, all those things you have to go build and make. And so I don't care who you are, those are things that I'm saying them because we've been down that path and we've had to, you got to build to make it work. And so there's a bunch of things you're going to get wrong, and you got to have a lot of time, a lot of money, a lot of patience, a lot of people to sort of power through that phase, and also to think that you won't make the same mistakes others made. You will. You will. That's another one that's it's interesting, because I had those things. We're smarter. Well, we won't do this, we won't do that. And it turns out I'm looking back, going, man, we made a lot of the same mistakes. So you got to have the time, the tenacity, and the people to fight through a lot of mistakes you're going to make. It's a very messy process. That's the first part of that question. The second part is whether you're a big company or small, the scale you choose, I think, is critical. That starting scale, and if you're a large company that may have a very small scale, a lot of overhead, that cost structure may not be appropriate for where you're going. And if you're a small company who's doing bay build, unsophisticated, development, that doesn't scale very well either. So it's tough. Hang on.
Well, that's exactly why I thought it'd be really great to chat with you, because it's important to pepper some of the projections that we're making, which we think are really real, with the reality of the fact that there's this physical system that has to get built, and that is going to have to be for that metronome to tick for us to get these vehicles produced at scale. There's a bunch of problems that have to get solved, and there's going to take an ecosystem of people working across different slices of the industry, I think, to really solve that and to get it to the scales that we want.
For sure. I mean, you have to address all these problems at once, because if one segment of this risk, doesn't pan out, the whole thing doesn't work. So you got to do what we're doing and solve it all at once.
Starting, frankly, with the demand side of it. That if you don't believe that there's this demand for these things, you can't make the investments necessary to get to the scales, and that virtuous cycle never kicks off.
Right.
Yeah,
it's true. I will say one thing that I'd be a little careful with the automotive, because I went through the same process, and making the physics of making a flying machine, particularly one that you want to productionize and duplicate over and over again with high reliability, it's orders of magnitude more difficult, in my opinion, than making a car. It truly is. Nothing. I used to admire cars. After making an airplane, I'm like, my God, it's the things to do it right. If you want the reliability that we're talking about, particularly if you want commercial grade reliability, it's phenomenal. The human system today, the airline infrastructure, is incredible. And so the sheer physics of that problem drive you into corners of envelopes that are challenging from a design and manufacturing standpoint. That's just the fundamental. So you don't get the economies of scales don't solve all your problems.
Yeah, so
some of them. I'll solve all of them.
And then specifically, it's particularly painful on the aerostructure side of things. That's
right.
It's kind of the whole ball.
That is the pain point.
Yeah. So actually, digging into that a little bit more. So you actually set up. I visited your factory up in Vacaville. I haven't got a chance to go to Tijuana yet. Soon, hopefully. You set up a car-style assembly line at the factory in Vacaville. And what kind of efficiencies or lessons learned did you get out of that, or versus kind of maybe the more traditional way of assembling vehicles?
I can't answer that because I've only done it this way, so I don't have a good perspective of how we are better or worse than others. I'll tell you that the assembly side for us has been pretty good. We set up I hired folks out of the power sports and car industry, sort of take those lessons learned and kind of sort of bring airplanes with power sports and cars. And we set that process up the way that they're familiar with it, and it works well for us. So I'm a big fan of the assembly process that we have together. Again, assembly is not the gating factor, challenging part for us. The real difficulty comes in building the structures.
And you guys use pretty much right now in the composite factory, you're using fairly traditional techniques and methods.
Yep.
Okay. In terms of like how you built out your team, like the team that you construct, like you just mentioned that you hire people out of the power sports and automotive industries. Is that where you've primarily looked, or have you kind of, in terms of building out your production side of things, I assume you shifted from design into production as you...
It's a hard transition, by the way, organizationally. You have to change, because you have to not just design an airplane, you have to design a company. In our case, it's a new company, so you have to design the product. You have to design the machine, then build the machine, then design the machine that builds the machine, then test the machine that builds the machine. That whole process. So what you end up building is for us, the hardest work is building the organization that actually can do this. And that's all people, you know. And I don't know if there's one panacea for where you hire from. I mean, because a lot of things that we bring from the automotive world, which the people who grow up in the automotive world, the scale is so different that you take for granted underlying assumptions from there on volumes.
Like what? Yeah, what is an example of an underlying assumption?
Oh, well, I mean, when you're going to amortize something over millions of vehicles, right? It's different than amortizing over the thousands. And people, they jump past that in their thinking and their tooling costs and everything else. So, and they're used to massive organizations and massive overhead and massive support. And a small company for us, you know, these things can be a whole lot leaner. So, yeah.
So you kind of mix it?
We mix it. I mean, we try, and you know, you look at the boating industry because the volumes can be a little bit, but the technology's not there. There's some danger there because, you look at a boat, and it's composites. You know, it's fiberglass.
Not the same.
A tree's composite. Wood's composite. Right. But again, on the spectrum of composites, from wood to a boat to where you will need to be and we need to be, we're up here near satellites. So getting people that understand fundamentally the difficulty and the physics of the problem you're trying to solve is critical. And I don't have a panacea there, you know, Eric. It's just building organizations is hard.
Yeah.
Fun, hard.
So, so what's next, do you think, for you guys? Just building more airplanes?
Through it. We're still fighting through it.
Yeah.
We built 40, 50 of them now. You know, ramping production and selling.
Yeah. At what point do you think that you're going to get to hundreds coming out of the factory per year? I don't know if I can ask you that.
Yeah, so. I mean, but you know, we're looking to scale to, knock on wood here, a rate of about 1 a day by the end of the year. Workday, so
that's
about 20 a month.
Yeah. That'll make you the largest smaller manufacturer.
That's puts it over sort of Sears.
Basically, yeah. They were about 350 last year, I think.
Yeah, about Sears level, in that range. So, yeah, I mean, it's a lot. It's getting quickly is tough to do.
Yeah. Well, any parting thoughts that you'd like to share?
No, not really. I mean, it's cool. It's cool times. I mean, I'm really excited about this because you have to sort of take on this problem at this level across all these dimensions to make this thing work. And it's risky as hell, but if we can solve it all, I think it will work.
Yeah. Well, thank you for your time today.
Glad to be here.
Thanks for the conversation, and looking forward to chatting with you more in the future.
Cool. Thanks.